of them. We did several roundabout intersections, mini roundabouts and, restricted, crossing U-turns as well. So that got us through that, and then because of that, we felt like we needed some more guidance. So that's where Jill and Jeff jump in, and they helped us, with the guidance for intersection control evaluation. So that's our current research project. So our goal with this project was to incorporate the evaluation of intersection alternatives into the project development process. And with that, our goal was to address, operational efficiency, safety of all users, and performance sustainability. So, with this project, we determined how to properly justify and document intersection designs for a project, and wanted to ensure that alternative intersection designs are considered and evaluated for KYTC projects, while continuing to meet the purpose and need of the project. So that brings us to this webinar. So with this webinar, we're going to go through the what, the why, the when, the where, and the how, for intersection control evaluation. We want to do this so that all designers know what ICE is, why it is needed, when it should be used on your projects, and where it will be applied and how to apply it. So hopefully that was a decent introduction. And, by the way, I'm Wendy Southworth. I'm the TEB for the Quality Assurance Branch here at KYTC Highway Design. And, Jill Asher will actually she'll be presenting, and going through this webinar with you all. So with that, Jill, you want to take it over?
Sure. Thanks, Wendy. Thanks for the
You're welcome.
introduction. And good morning, and thanks for everybody that could attend today. Really appreciate it. We're going to talk about ICE here in a minute, but before that, I just want to make sure that you've had the opportunity, if you haven't already, to download some of the files. I think Jeff's been putting the links to it in there. Later on, if you learn better about like going around along with the examples, then there's these spreadsheet tools that you can use to go along. And so most of them are available on that NAS website. And if you brought it up, the link to it, it looks like this. And you need to scroll down below here to the resources. And we'll talk a little bit more about this NCHRP later on. But as part of it, several of the tools were developed. And we last year put together a ICE workshop with KYTC folks from districts, divisions, different divisions that helped us put together this guidance for KYTC. And so we talked about some of the tools we would use then. Well, since then, a lot of them were updated or there were more tools added. And so we met again, and the tools we're going to be using this morning are the first part are going to be the CAPEX, this SSI calculator tool for intersections. There's one for interchanges too, but we're going to use the one for intersections. We're going to take a look at the PPEHD ICE tool here, and also the SPICE tool. So the safety and performance for intersection control evaluation. We'll probably have time to look at a couple of the optional tools as well. So some of the optional tools for the ICE process is this design flags calculator tool, and also this life cycle cost estimating tool. So if you get a chance, kind of download those if you haven't already. There's a couple of other downloads for the KYTC ICE form. And then also there's some information where we're going to go through an example later on. It's just a Word document. And so before we get started, everybody kind of get familiar where your emojis are. So you can give me a thumbs up every once in a while. So I know somebody's still out there listening. They should be somewhere on your Zoom menu, maybe at the top. And then also, if you have questions, I see some good job. If you have questions, go ahead and post them in the chat. There's going to be a couple of times during the webinar that we'll stop and answer questions. But for during the presentation itself, I think everybody's going to be muted. All right, so we're going to go ahead and get started. Oops. So just for a little bit of interaction, just to get started, everybody's still just waking up. This isn't a mini meter or anything. You can either put the answer in your head or you can put it in your chat. But what do you think that approximately what percentage of reported fatal crashes on Kentucky's roadways in that 5-year period from 2017 to 2021 were at intersections? How many do you think? Excuse me. But I see a lot of Ds, and so actually in Kentucky, it's actually around 20%. And so you can see the little graph of the figure on the right, that's FARS data from 2021, and it compares county data nationally. Red's not good. It does it on a rate basis, so it's kind of spread out all over Kentucky as far as the high rates. So like Wendy said, we're going to talk about, the what, the why, the when, where, and for the most part, we're going to spend a whole lot of time on the how, like there's a lot of resources available and how you might apply them for the process. But first, we're going to start out with the what. What is ICE? Well, ICE is a data-driven performance-based framework to screen intersection alternatives and to identify an optimal solution. And usually it's done differently in different states, but usually there's 2 stages. And that first stage is the screening. And then you screen through intersections, find some feasible ones that you want to move forward to a more detailed analysis. And you do that in your alternative selection, and that's called stage 2. And so ICE isn't really new. A lot of states have already adopted ICE policies. In fact, this map is a couple of years old now. You can see that I know since then, several more states have adopted ICE policies. I heard about it several years ago when Florida DOT did a presentation at a conference that I went to. So it's been out there for a little while. And again, it's intersection control evaluation. There's a lot of acronyms. It's not independent cost estimate. So it's intersection control evaluation. And so basically for KYTC, the process, this is the flow chart, is you have your stage 1. That's really your very high level screening process. You look at different things like your capacity and safety at a very high level. And you answer some feasibility questions too about intersection types. And you report that on a form. Now, it might be that in your stage 1 that you have one alternate that's really the only viable one or one that really stands out. If that's so, you could document that and you could advance that alternate through the design process. But more than likely, you're going to have several intersection alternatives that screen through, or maybe not several. There's no minimum or maximum number of intersections. This process needs to be flexible. It needs to fit the size of your project. So there's no minimum or maximum. But you'll probably have 1 or 2 or 3 that may screen through to your stage 2 alternative selection. And that's where you do more detailed analysis. And, you look at your traffic, your costs, impacts. We look at all users and the context of the area. And then we have it's the same form, but it's a different tab on an Excel form where you fill out some information. And it's actually made part of the design executive summary. And so the approval of that intersection occurs with the approval of the design executive summary. They're not necessarily separate processes. And so if you have an intersection on your project, how do you know what the best alternative might be for that location? Maybe it's a roundabout or an R-cut. But in project development in the past, and we're getting better at this, but we didn't spend a lot of time talking about different types of intersections. We looked at different typical sections and different alignments, whether we go left or right at the center line. But this ICE process, it really encourages the comparison of feasible intersection alternatives. And in support of that, there's a lot of tools that's been developed. But some of the innovative intersection types that you might want to consider, again, are roundabouts, R-cuts, continuous green T's, median U-turns, quadrant intersections. And so ICE allows us to compare the performance of those innovative intersections to the traditional intersections like signals or stop control. And we're not going to spend a whole lot of time in the webinar talking about all the different alternative intersections. There's been some presentations on that in the past. There's been some classes, partner conference presentations. Jeff probably has some links to these. He also, I think he posted the presentation maybe, so it has links to these sites. That Safer Solutions, if you haven't seen that, it's a really good marketing tool for different types of innovative intersections that KYTC has developed. And then back in 2019, Mark Doctor came to the partner conference and he gave a presentation on innovative intersections and interchanges, and that presentation is available as well. FHWA has a pretty good intersection control evaluation website. And then also, if you're unaware of it, KTC's T2 program has a Road Safety Champion program. It's actually a nationally recognized certificate-based program, and it's designed for local roads, but a lot of KYTC folks go to it, and they actually has one of the classes in it is called alternative intersections and designs. And so it's a pretty good class I sat through the other day. So, there's a lot of information. In addition, that NCHRP 1087, in the appendix of it has information on all the different intersection types and when you might want to use those. So why does KYTC want to do this? Is this just another thing that you have to do? Well, there's reasons that we want to look at ICE, and the big thing is safety. So the safety of intersections. We want to start looking at some of these intersections that have less conflict points, that manage speed and crash reduction. And so also, some of them offer some potential for less delays and congestion. Also, in making it the opportunity to look at all of your users, what kind of facilities you might want to include for those, and value. So not just looking at the cost to build necessarily, but the value of the intersection and how maybe it accommodates more users, how it maybe eliminates crashes. So there's these comprehensive crash costs that you eliminate, or these long-term maintenance costs of some of the intersections. So all of that is you need to consider in this ICE process. But again, the big thing is, excuse me, the big thing is we would like to have some safer intersections. And so these innovative intersections, you've seen this comparison of traditional to roundabout, you're reducing conflict points. And so again, you may not select the innovative intersection, but you want to bring these to the table when you're making your decision. They need be part of the decision-making process. And so just to know that, if we reduce conflicts, then there's less likelihood of collisions. But also bringing into the picture that kinetic energy. We know that the human body can only withstand so much kinetic energy. So we really want to reduce those fatality and serious injury collisions. And by doing that, we need to reduce the kinetic energy of collisions when they do occur. And so, if you can see from the equation of kinetic energy, your speed really factors into that. And so if you have a car that's going 60 miles per hour, it has 4 times the kinetic energy of a car that goes 30 miles per hour because it increases exponentially. And so what about the angle of the collision? Does that matter? And so I guess just for some background, that picture is actually my daughter's car. There's nothing like getting a call in the middle of the night and her airbags and all. She had rear-ended somebody that was turning at an intersection. And so she was fine. But one of the reasons I think that she went home with us instead of in an ambulance is it was a rear end collision. And so I know this slide is busy, but angle does contribute to the severity of the collision. So if you can see down here at the bottom, let me go ahead and get the highlighter. And she had that less car for less than 2 months, so it was an inconvenience. But she went home with us. I was very grateful. But so this is 0 degrees here. So that'll be like your rear ends and side swipes. And so if you see as the speeds of both the vehicles increase, your probability of having a fatal or serious injury collision. So if it's greater than 50%, it's red. And if it's less than 10%, it's green. So what you're wanting is you're wanting more green. And so you're seeing green down here for those vehicles that are going basically in the same direction. But when you get to your 90 degrees or your head-ons appear at 180 degrees, you have more and more red, which isn't good. So these are national numbers, but they're still pretty effective. The right angle collisions account for over 40% of fatal crashes at intersections. And then those left turning crashes, they account for 20% of fatal crashes at intersections. And as we know, the amount of pedestrian fatalities seems to be increasing. And so that the ped bike crashes account for 25% of fatal crashes at signalized intersections. And here's an R-cut. So I really like these R-cuts because I don't like to turn left across lots of lanes of traffic. And so what this does is it instead of turn left and having all those conflict points there that are fairly severe, you're going to turn right and you're going to make that U-turn. So you might have some side swipes, but you're not going to have those angled collisions. So when do you use ice? When do you apply ice? Well, again, you want to do this as early in the process as possible. Maybe even, you can make it part of the planning process, but certainly in preliminary engineering, at the end of preliminary engineering, you should be done. And so it's not a separate process. It runs concurrently with your other project development activities. And again, if it goes past preliminary design or preliminary engineering, it's just a lot more difficult to implement. It's more costly and there's more issues. So you want to try to do it as early in the process as possible. And so where do you apply ice? And as I mentioned, we met with KYTC and brought in folks for the workshop from the divisions and the districts, and we talked about this a lot. And so basically right now in the guidance, it's for project development projects, for those capital improvement projects. Some other states use it for their, if anybody has a permit application for an intersection or maybe even an application for a traffic signal, they'll use it for that process. But right now, if you have a project and it has an intersection on it and it's on a state maintained roadway, then you would need to do an ice. And so there are some exceptions. If you're not doing any substantive, if you're not changing the intersection's geometry or the control type, you're not changing anything like that, you wouldn't necessarily have to do an ice. And also, if you have volumes on your side, on your approach roads that are pretty low, you probably could justify not doing an ice. And so this is where the possible exceptions are. If you have traffic counts available, which a lot of our county roads, if you have intersections with county roads, they don't have traffic counts available, but if they do, you can go to CDAT, and with the crash data access tool, and you can look at the EECs for the intersections. And we'll talk a little bit more about what those are here in a minute. But so if that is less than 0, if you have no notable crash patterns, the minor road AET is less than 400, and there's really not any operational issues, then you can just document that, and you probably wouldn't have to do an ice. If you don't have traffic counts on your side streets, but you know that there's no notable crash patterns, the minor road doesn't serve any users, and there's no known operational issues, you probably don't need to do an ice. And so if you're not familiar with some of the acronyms that were used on the previous slide, CAVCO is just measure a severity of the collision that's reported on the crash report itself. And so those Ks are your fatalities, and then Ks, As, and Bs are really your fatalities and injuries. And then O's like property damage only. The EC, excess expected crashes. So the line that you see there is a safety performance function. If you're not familiar with that, I'm not going to get into a lot of details. It gets pretty complicated, but it's just a way to measure the safety on your roadway. And so for a certain type of roadway, you'll have an SPF. And if you measure above it, then on there, your excess expected crashes are the difference between the crashes that your roadway's experiencing and then the what it should be on that SPF line. It's above 0, and that's kind of where you want to look at your safety and do an ice on that previous slide we were talking about. If you want more information on these things, KYTC has a DDSA implementation plan on its DDSA site, data-driven safety analysis. And it goes into a whole lot more details on both CATCO and EDC. All right, so a little more interaction here. Approximately how many modern roundabouts are in the United States? This is United States, not Kentucky. So is it 2,500, 6,000, 7,500, or 10,000? Again, you can answer in the chat, or you can just answer in your head, whichever one you think you'd want to do. Okay, so I'm seeing a little bit of everything. But the answer is there's about 10,000 roundabouts in the United States, and Kittleson and Associates keeps a database of the roundabouts. But there's approximately around 78 in Kentucky, including local roads that we know about. So you know, there's more and more all the time. And if you want to know where the alternative intersections are, there's a map. There's this alternative intersection in Kentucky map, and as part of when we were looking at ICE, we asked the district to send in the locations of their alternative intersections and interchanges, and so that they did. And OIT, KYTC developed an interactive map. You can access it through KYTC's Highway Design website, and also I think Jeff just put it into the chat. And so, but this is a good time too to talk about interchanges. So the KYTC ICE guidance focuses on intersections and applying ICE through that. You can use ICE for interchanges as well. It's not required, but there's a lot of tools out there if you want to use them for ICE on interchanges. You know, the interchanges usually have a lot of, you know, IMRs and IGSs, and they have a pretty detailed process anyway. But there are tools available to apply ICE to the interchange process. And so one of the reasons I think the map might be helpful if you're a project manager and you're considering one of these alternative intersections, but you have questions about how it was built, or you want to go out and look at it, you can see where they are. You know, you can contact people in the district and ask about them. Most of them were probably built as part of HSIP projects, but I think more and more we're trying to include those in some of our project development or capital improvement projects. And so, yeah, it's a pretty good map. All right, so now we're going to get into where we're going to spend like the bulk of our time today. And that's going to be the how. So what resources are available and how they're applied. And so, you know, we talked about that stage 1 screening. And so basically the process is you go first, you probably put it through the operations analysis, very high level process. And then you put it through the safety process. And then, you know, you want to eliminate non-competitive options. You're going to ask some practical feasibility questions as well. And so it uses tools that were developed in coordination with this NCHRP 1087. It's called a guide for intersection control evaluation. And so when we first started looking at ICE, that document wasn't available. We developed ICE. So if you went to the partnering conference on the 3rd day last year and we presented on ICE guidance, it's since been updated because they came out with this new SHRP 1087, and we updated the ICE guidance. So that's what's on the Highway Knowledge Portal site right now, the updated guidance. And mostly it didn't change a whole lot. What did change is the number of tools available, and then it updated the tools that were already out there. So if you, how many of y'all have ever used CapEx or SPICE? If you could just give me a thumbs up if you've used it before. If you've used it before, you probably used the previous version. Since then, they've updated, and I'm sure they'll make future updates to the programs or the spreadsheets as well. But they updated as part of this NCHRP process, and you'll see that as we go through the spreadsheets. So I do want to say something about these spreadsheets, and there's, like I said, there's several of them available that they developed through this process. They're very high level or planning level analysis. You're not going to time your traffic signals on them. They're not going to fit every situation perfectly, but they are free and they're user friendly. CapEx uses predicted lane volume for analysis, so you don't have to have necessarily a traffic signal number. You know, you don't have to have information for signal timing. And it also provides ped and bike accommodation, safety numbers. And then also, the SSI is very easy to use, very few inputs. So they were developed specifically for this high level analysis of looking at alternative intersections and traditional intersections across the board. And something too is throughout the process, we need to be flexible. Again, you're going to have some intersections that are really complicated, and so they'll require more analysis. And you're going to have some that are not. And so you want the amount of work you put into this to be really commensurate with the level of complexity of your project. And also as part of stage one, you have some of these questions. Again, you're high level, you're either at planning here or you're at conceptual design, but you know the answer to some of these questions, like is alternative practical to implement, considering the initial cost, but also the operating costs and potential environmental impacts and other impacts. Does the alternative for the intersection meet the purpose and need? And then does it consider the needs of all users? And so just a little bit more about CapEx. It's a very high level spreadsheet tool. It requires minimal inputs. It does require turning movement counts. And so that may not be something that you have, but it does require those. There may be ways to use, and I would talk to the Division of Planning, there may be ways to use streetlight data to get some of these counts if you don't have them. And it doesn't address every detail of an intersection operation. And so I just want to stress that if you put an intersection, if you do CapEx on an intersection and you don't feel comfortable that it's really justifies the actual capacity of an intersection, or it doesn't, and there's a lot of assumptions, and it'll show those on the tools. Some of the assumptions it makes really doesn't represent your intersection type or your situation, then I would strongly suggest you take that intersection alternative and move it on to stage 2 and look at it with another program. For the most part, I think it does a good job at that very high level, but if you're uncomfortable with it screening out that intersection type early, then you can go ahead and move it on to stage 2. So as I said, you have, so it provides CapEx does a couple of things. It uses critical lane volumes to find a VDC ratio for intersections. And then also, as this updated version of CapEx, the previous version had multimodal tabs as well, but they've updated using Ohio DOT spreadsheets, and they have a bike ped accommodation rating. And so we'll go through that as well. I told you we have to have turning movement counts and truck percentages and some other roadway characteristic information. So there are some websites that have that, some of that information available. And then also CapEx, and that's the download from the NAF site. So FHWA Resource Center has that FHWA ICE page out, and it actually has a really detailed user manual for this CapEx program. But again, it was based on the 2018 version and not the updated versions. But most of it's really the same except for those 2 tabs, the multimodal tabs. And then SSI is that Safe Systems for Intersections, and it provides a score from 1 to 100, with higher scores being more desirable. And so there is an SSI tool for interchanges as well, but we're just going to go over the intersection one. And it provides a safety assessment based on safe system principles. So it's looking at intersections that remove or reduce the number of high angle collisions, conflict points, and reducing speeds and exposure. That's what that's based on. It has very few inputs, but it has a lot of stuff going on in the background. So you can input your road AATs, the number of through lanes, and the posted speeds, and that's really the only required. There's some optional information you can provide as well. And again, you can download it from that same website. And so this is some of the websites that, and there's links if you have this PDF, but there's links to these that provide some of the data that you'll need to go through that stage 1 process in addition to the downloads. And I was going to introduce you to the stage one screening form. So that was one of the things as well that there should have been a link in there. It's a spreadsheet that was developed as part of this process. When you get to it, it's just a spreadsheet. I think most of the people on this call know how to use a spreadsheet. So if you need to alter it by adding lines or something like that, you should be able to do that. There may not be enough room to provide information. If you have a lot of things you want to put in here, and you can just make those cells bigger or make another sheet. But this is the stage one screening form, and we'll look at that in just a second. Right now, I'm going to go to the example. So this is where we're going to start our example. Let's see what time is it. Oh, we're doing good on time. So there should have been a download to a Word form, and it was pretty simple. Let me show you what it looks like. And this might look familiar to some of you, but I've changed it a little bit, so it's not your project. If you think, hey, that's my project, it's not. I did get some information from central office on a project, but I kind of altered it for this example. And so it's a picture of the area. The purpose of the project is to increase the safety and mobility for motorists, pedestrians, and bicyclists along the corridor. And then I provided some information for both a major and minor approach. And so the north-south direction, which is generally, I don't know if you can see my cursor or not, but it's generally this direction, the one that's not the one leg. So that's your major direction. And we've been provided information on current AETs and future AETs, so projected AETs. Right now it's 14,000, and in 2044, 19,000. It's currently a 2-lane roadway, but they're going to reconstruct it as a 3-lane typical. And so there are no existing turn lanes right now at that intersection. There's also no existing sidewalks, bike lanes, or shared use paths. For simplicity's sake, we're saying there's 5% trucks on both the major and minor approach. The posted speed limit on the major roadway is 45 miles per hour. It's an urban arterial. The minor roadway. So for the sake of our example, right now there's construction going on in the quadrant where there's not a road. So they're building a road here, and we have projected volumes for that. And so if you have just one AET to use, you would use the larger one when you're entering in the, if you have for each leg in that direction. So it has both the current AET and the projected AET. The minor street is a 2-lane roadway and stops right now. It's a 1-way stop control, but we're going to model it as a 2-way stop control because there's going to be another leg there soon. And it has a left and a right turn lane right now. We talked about the development. We have forecasted traffic numbers, and the posted speed for it is 35 miles per hour. And then we're provided some peak hour counts for our mainline roadway for both AM and PM, with the AM peak really being the one that we're going to look at. All right, so if you have room on your screen, if you have a couple of screens open, you might want to go ahead and get your CapEx out. I'm going to go ahead and stop. So stop the presentation for a second and bring up the spreadsheet. And I call this portion of our webinar Fun with Spreadsheets because there's a lot of them. So I hope you enjoy spreadsheets. Right. So if you bring your CapEx spreadsheet up, it should look like this. You know, one thing about these spreadsheets is, again, they're free for us to use. They're easy to use. They have minimal inputs. They're not. There's also what comes with that is they're used as is. You'll see this in all the spreadsheets. This product is available as is. There's no technical support for these, and they're developed mostly to provide to the DOTs, and then they take them and modify them as they need to and do their own. Most of them have done their own support for it. So we're going to use it as it is. And again, it's been out there for a while. It was updated, but people have been using it for a few years. So in CapEx, there's a lot of assumptions made. So if you go to that next tab, abbreviations and assumptions, it's going to give you some of those assumptions so that you know what they are. Like if you're looking at an intersection and it's just not quite fitting into the mold for what CapEx is requiring, you can probably come here and look and see some of the assumptions that it's made. But one of the things that you really want to look at, and I'll make this a little bit bigger, is this shared lane configuration option, because you're going to have to enter in these, you're going to have to code how your lanes are. And so at this point, you may not know if you have, what kind of turn lanes or if you have a right turn lane, if you have a left turn lane. So you can do different scenarios and see how they come out through CapEx. But in our example, our main line is going to have a through lane, a left, both directions will have a through lane, left turn lane, and a right turn lane. And again, it just has, it's just going to be, 2 through lanes, so not one in each direction. And then our minor street is going to look like the one on the right over here. It's going to have a left turn lane in each direction and a right turn lane and a shared right turn lane and 3 lane. And you can see the change log from the time it was developed in 2018 to now. And the biggest change that I've seen is they have started using the Ohio DOT's version of the multimodal tabs, and we'll look at those in a minute. All right. So the first part of your spreadsheet on your inputs, and it will tell you, usually all the spreadsheets will say what color is your input. It's usually yellow or beige. And so in this case, it's yellow. Everything that's yellow requires an input. And then there's some optional inputs as well. But the yellow is required. And so we're just going to call it, I'm going to type these in the first time as far as the traffic counts and things. And then for the other spreadsheets, probably will not. But if you want to follow along, you can. It's pretty simple. We're just going to call this example. Oops, I can type. We'll say the project number is maybe 14 dash. The date, it could be today's date. So it's May 23rd. And so this is kind of important. Even it says 4 already, so that's the default. But if you don't pick 4, it doesn't change some of the settings it needs to in the spreadsheet. I'm not sure why, but I've just found that to be true. So I'm going to go ahead and pick 4, and it does some different things here in the spreadsheet because we have number of legs on your intersection is what that's supposed to say. And then your major street direction, we said that was the north-south. So we're going to pick north-south. All right. And then you would put your traffic numbers here. That's what was provided in that Word file with example. So I'm just going to go through here, and we didn't have any U-turn counts. So I'm just going to go through here and put in the numbers for the traffic. And then if you're not provided that percent heavy vehicles, make sure you can find it in your traffic data, because that's really important. And for simplicity, we're just saying 5% across the board here. And then our northbound, which is our major movement, is northbound in the AM. So. All right. change that to 5% as well. All right, so you've entered in your PM, and now keep in mind too that these are your forecasted volumes. If you don't have those, you can use your current volumes if you have them. This volume growth rate, if you don't have a forecast, you can talk with your project development team and figure out, look at the context of the roadway, look at land use plans if you want to, and try to figure out what you think your growth rate will be over the design year of your project. And this is not applied yearly, it's an overall growth rate from the year you build it to your design year. So just keep that in mind as well. But we're using forecasted volumes, so we'll just leave that at 0. Adjustment factors, those I think came from the highway capacity manual, so we'll just leave the defaults, the suggested values. Same thing with the passenger car equivalent. All right, so we're going to talk more about the multimodal a little bit later, but I do want to say on the previous version of CapEx, what I think this is, and I haven't been able to get quite a definite answer, but I've talked to the FHWA Resource Center, and they think that what this is too, is the level of multimodal activity. And so it's before it was just one entry, and now it's several. And so I think it's by, of course, the leg, an approach leg, and then it's by pedestrians, bikes, and then I think it's an overall here. The one thing is it doesn't really link to anything, so it doesn't apply any numbers anywhere else, or not that I can tell anywhere, and I've looked in a lot of detail here. So we'll talk about this later, but I don't think it really does anything. You won't necessarily have projected POD compet numbers, but you would have to make an assumption. And there are some numbers, and we'll talk about later on, that represent low, medium, and high for activity levels. And then we're just going to leave this as it is as well. This is a suburban area, so we're going to use the suggested urban values for your critical volume sum limit. All right, so now we can go to the next tab. A lot of tabs, a lot of spreadsheets, and the existing intersection configuration. So we're going to say that it's a two-way stop control, because that's what we're going to use as our base for our existing condition. And then we get down here to this alternative selection. So CapEx has the ability to look at capacity of all these intersections really quickly. I mean, there are a few other places where you have to enter in individual information for different types of intersections, but it does it really quickly. So you could look at all of them probably. But when you get to the multimodal tabs, there's a little bit more, it takes a little more time. So I'd really encourage you to pick out ones that make sense, that are feasible for your intersection, and try those out. Like, you come down here, you're probably not going to do, in this area, you're not going to do a grade separated intersection. So we can go ahead and say no on that. And you're also probably not going to look at interchanges. So that kind of knocks all of those out. And then you still want to come back up and think about it. We definitely want to look at a traffic signal. We're going to use two-way stop control as our existing conditions, so we're going to leave that in there. We'll look at the always stop control. It automatically eliminates the continuous green T option because we put it in as a four-legged intersection. This quadrant roadway, so we could look at that as well. That might be overkill for this situation, so we may want to eliminate it here in a minute. But what I would say is, you do have to build an extra leg sort of part of your roadway, and so not only is there extra cost, but there's also right of way and other impacts, and so you want to consider that. But it might be a good option where you are for the traffic numbers that you have. The traffic here probably isn't quite heavy enough to justify it, but let's take a look at what that looks like. And since it's already developed in most of the quadrants, we're going to just see what the quadrant, putting that leg in the quadrant that's not developed, which is that southeast quadrant. So we're going to say no here. We're going to leave yes on the southeast quadrant. All right, so this displaced left turn, I don't know if we have any of those in Kentucky. I don't think so, but that's probably beyond what we need to do for this intersection. Again, you can get some of that information from those links about what might be appropriate for your area that we talked about earlier. So as much as I really like R-cuts, they don't really do well if you don't have a divided roadway, making that U-turn and all that. So we're gonna say no on these as well. But I really encourage you all to kind of play with this later on just to see how some of these intersections look like in different situations. So really anything that has a U-turn. It takes a little bit for the spreadsheet to function through that. So, and then that bow ties is basically taking all your turns and put them on roundabouts on either side of your intersection, which sounds like a good concept, but it also takes, in this situation, right away that we probably don't have and might be a little bit, you want to right size your intersection. So, and then the split intersection, that's probably a no on that as well. Okay, so we have some of these traditional intersections up here, and then also we want to look at some roundabouts. And that 50, I'm just gonna, I'm not necessarily an expert on roundabout, but I'm gonna say it's a little too small for the number of trucks and the number of cars we're going through here. I actually would say 75 is as well, but we'll leave that in there just to look at it. And the 1x1, yeah, definitely we want to look at a 1x1 roundabout. We have one lane going into this and one lane coming out of it, so that would make sense. However, you know, if there are issues with capacity for your 1x1, you could look at the hybrid and you could widen out to 2 lanes to go around part of it, maybe one part of it or 2 sides of it. And so I'm going to look at that, and I'm going to look at it in the north-south direction with the 2 lanes because that's where our main line roadway is. And so we could look at larger roundabouts, but if these smaller ones work, we really don't want to look at a larger one. So we can always come back to those if we need to. Okay, so now we've picked out some of the intersections that we're going to go through CapEx and look at. And we need to go to the next tab we need to go to is 3, so we can put in our lanes, number of lanes. And you can click up here. Again, we're just going to look at intersections only today. So we're on tab 3 and putting in your lane assignments. And I showed you again on the you know, on the assumptions and abbreviations. If you go down to the bottom of it, it shows you how to code some of these in for your different types of scenarios. So just keep that in mind as you're going through your lane assignment. And as I mentioned, we're just doing 1 through lane in each direction. So that's where we would change this here. And so for the traffic signal, we said north and southbound are going to have left turn lanes and right turn lanes, but the eastbound and westbound, the minor approaches, are going to have a shared right and through lane. So to code that correctly, you would need to put 1s in here. And then your eastbound would be 1 direction, and then you don't have a right turn lane, so it's combined with your throughs, and that's how you would code it. Same thing we're going to use for the 2-way stop control, so we'll do that as well. Okay, put that up. And then all-way stop control, let me see. And if you go down, that's really the only entries that you need to make for that. Now, sometimes if you pick a certain type of intersection, it will tell you to go to that tab. So like the quadrant roadway, and we didn't, I don't think we picked, yeah, we did pick that one, I'm sorry. So if you need, it has different individual entries for that. And the reason being, you know, the quadrant has 3 nodes. So you have to put in the number of lanes for each one of those. And they're over here. So you can put in 1, your again, it just has 1 3-lane in each direction, so you would need to change all of those to 1. And you can try different configurations. All right. So we've coded all of them. If you look, everything's taken care of. We took care of our quadrant. And so now it gives you the results, and you can go to the detailed results and get it an overall, but then I would actually encourage you to go to each individual tab. So it shows you, in most cases, like the individual legs and which ones failed, if they failed. And so you can see the traffic signal, and again, keep in mind that these are projected volumes. So 20 years into the future, it performs at a 0.84, and that's for the overall. Two-way stop control, it does not do well. The all-way stop control, it fails at some point along the way. It's 1.3, and so the quadrant roadway, it actually works very well, maybe too well, so it might not be quite right size for your intersection. It didn't like the 75-foot diameter roundabout, the mini. The one in the future has a overall capacity of 1.1. We'll take a look at that in a minute, and then the hybrid, the 2x1. Has a capacity of 0.7. So if you go to each individual tab, it shows you the overall for V to C ratio for the intersection if it's signalized, and so that's what that looks like. Then it shows you the two-way stop control, right? It doesn't do very well in the future. All-way stop control also kind of struggles. And then this quadrant roadway, you can see it does well overall for the overall intersection. And that's one thing about these CapEx and some of these programs that are developed just for the alternative intersections is if you did this in like HCS or some other program, you would have to do each individual node, and this kind of is high level, so it just does the whole intersection. There's a really heavy northbound movement, so that, and I guess the size of it really, it came back with a very high V to C ratio for this mini roundabout. So we're not going to take that any further. We're going to click off of that and not look at it. All right, so the 1x1, I'm going to take a little bit of time to talk about this 1-lane roundabout. And so you can see most of again, we need to keep in mind that these are projected volumes 20 years into the future. And most of these movements work. So most of them are under capacity or not quite to capacity in the future. The one that's not is this really heavy northbound movement. And so there's things that the CapEx doesn't do. It doesn't look at right turn lanes, your bypass rights. And the other thing that you could think about for this 1-lane roundabout, because 1-lane roundabouts they have really good performance ratings as far as safety. And so one thing that you can consider is sometime in the future, we don't know when this is going to fail. You could see some sort of sensitivity analysis. You could look at making sure that you can expand this side in the future to accommodate a 2-lane roadway or a 2-lane roundabout, at least as a hybrid, but build it as a 1-lane right now. And so what I would say is don't not promote this option to stage 2 based on this 1.1 V to C ratio, because the chances are either it'll perform very well for a long time, and so you'll get that really good safety performance from it, or your volumes may not ever come to fruition. So at least promote it to the next stage, and so you can look at it in more detail with a different software, or you could consider how you're going to design it for changes in the future. But the 2x1, it does north and south, which I will say that we looked at. This has the AM traffic, which is northbound, so In the PM, it might be that you need to, that it does need to be a hybrid on both sides. And so it does perform very well in 2044. All right, so just going back, I'm probably not going to promote all of these onto stage 2 or even to the SSI process, but because it does take a little bit more effort to put in some of these multimodal entries. And so I'm going to go back and, oops. And the ones that really didn't work well, or we're not going to forward on to the next stage, I'm going to turn those off. I am going to leave the two-way stock control just as, again, as the existing conditions comparison, even though it doesn't function very well. I'm going to say no on the all-way stock control, so if it's over capacity. That quadrant works, it works really well, but there's a lot of impacts, so I'm going to say no on that. I just wanted a chance to show you what it looked like. And then as far as the roundabouts, I'm going to put this one works very well. So we're going to move forward in the next few tabs for the multimodal with the traffic signal, the two-way stop control, the roundabout, and 2 of the roundabouts, the 1x1 and hybrid. So you can go to the detailed results. Now these numbers here, the overall VHC ratio, are what you're going to use to go into this ICE form. So I'm going to take just a second to look at the KYTC ICE form. If you don't see it, yeah, just make sure and let us know in the chat that you can't see it. But it should have been a download, and the first page, this is the documentation that you're going to turn in as part of your ICE process. And the first page is basically some instructions. It tells you, that if it's beige, that's where you're going to put entries in. It has the download to all the tools. And then it also has some basic instructions for each worksheet. So stage 1 has a one form, it's one tab, and then stage 2 has a couple of tabs. And so for your stage 1 screening, you can see you have sort of the workflow of what you enter in on the left, a description of what's expected in the input fields, and then on the right, there's recommended tools and resources to find the information or to do the analysis that will give you the information to fill into these forms. And so if you take a look at that stage 1 screening form, really the first part of it is just the existing conditions and your project information that you would put at the top. You have your purpose and need, and then your existing intersection control right here. And then you want to talk, part of the ICE process is that context and equity. So you want to consider not only who your users might be, but why are they using it? Maybe you have, you're in an EJ situation where you have people that really need to go through this intersection to get to their jobs, and maybe they don't, it's a place where they don't use cars as much, and they rely more on transit, and so maybe they're trying to get over to the bus stop. So those are the types of things that you're trying to draw in with this section here. And it's land use for each quadrant you want to describe. And also the context classification, which if you're not familiar with those, it's a pull down, but there's descriptions in how designs guidance, and also AASHTO has these descriptions of the rural town, suburban, urban, and urban core. And so that's important too when you're picking out like facilities for all users. And then the second part of the sheet are your alternatives, your intersection control alternatives. And so you can have, there's a pull down, so you can pick those. And then you would place, like we just did, the CapEx. So this is where you would put those numbers. And we're going to go through the multimodal tabs here in a minute, and that's where these numbers come from that are in under B. So hope you're holding on. Lots of spreadsheets. We're going to go back to the CapEx and go to the multimodal PID tab. And I promise we're gonna take a break when we get through stage one, so. You can hear in a little bit, we can refill our caffeinated beverages and march on. So it gives you some instructions on, so we're on the multimodal head tab with CapEx. And it gives you some instructions, and some assumptions. And then, of course, these tabs that are yellow, some of them probably already have default values in them. And so, right here, our major street speed limit was 45, if you remember from the information that was given, and the minor approach was 35. This has kind of the defaults that you really want to see on your roundabouts as far as entry speeds. So 20 miles per hour for your minis, 25. So we're just going to leave those as they are. The information on the ramps, we don't use those for this example, so we're just going to leave those as well. Now, one thing that I do want to mention, because this was an issue when I first downloaded the CapEx form, and it's probably user error, it's probably some sort of setting on my part, but it had all these diagrams, which are very helpful, except it covered up the spreadsheet and you couldn't see the fields underneath. So if that's the case for you, if you have the same issue, if you just go to File, Options, and then if you go to Advanced, you can kind of scroll down to, I think it says Display. Yeah, Display. And click the one in Display. If you go down a little bit, it says for cells with comments, show indicators only and comments and notes on hover. And so even if it looks like you pick that again and say okay. And if they still don't go away, then you have to save the form and get back in. And that's what I had to do. Again, I don't know if everybody else had that issue, but that was a setting I may have had in my Excel sheet. So if you look at it, it gives you a graph of what the, let's see. It's not gonna do it. Hold on just a second. My hover over is not working. Well, let me see if I can fix that. Advanced. Okay. All right, well. Let me get out of it and get back into it and see if my, because it has some graphs that there are some visualization you're gonna have to look at and we'll talk about. So let me get out of this and get back into it. All right, so if you go back to the multimodal, okay, let's see. Oh, yeah. Now it's working. Oh, good job. So here we go. We're gonna go to the traffic signal, and I hope you can see the hover over when it pops up. For some reason, my hover over is not. Oh, here we go. I was doing the wrong one. Okay, so here it is. The traffic signal. So it has lane assignments, and basically, when you're looking at the pedestrian mode, you want to think about where you're crossing and how that aligns with these numbers. And so, again, if you're crossing that northbound approach, then, or I'm sorry, the southbound approach, but it's on the north. Then that one are all those incoming lanes. So you're gonna have to number how many lanes those are. And it's gonna be 3 because you're gonna have the left turn. It's gonna be exactly the way this diagram looks. I do want to say these diagrams are neat, but they don't necessarily represent your situation. It's going to be the same diagram all the time. So you're going to have to come up with your lane assignments and make sure it's supposed to carry through from the inputs, but sometimes it doesn't. So that's where we need to make adjustments. And so that movement of 1 and 5, that's going to be 3 lanes. All of the even numbers when we assign them are 1 lane because there's only 1 outgoing lane from in each direction. And so your 2, 4, 6, and 8 are you're going to say is 1 lane. And then on your east and westbound, there's only 2 lanes because you have that combined right and through. So that's just something to keep in mind as we go through. But I asked some other questions as well on the traffic signal, like is it going out of the direction of travel? And so the answer for all of ours is no. For some intersections, like your R-cut, maybe you actually bring in the pedestrians like go through the middle of the intersection, kind of over, and so we don't have any intersections where they just cross the crosswalk basically in a straight line. So the answer for all of these is going to be no for the pedestrians. And then is it a multi-stage crossing? And so if you have a pedestrian refuge between the 2 directions of travel, then that answer to that would be yes. We do not for the traffic signal or the 2-way stop control, so we're going to say no. And that wouldn't be true for the roundabouts because you're going to have that splitter island with a ped refuge, so you're going to have a multi-stage crossing. So these crossing numbers, again, they align with this graph here, and so you'll have to code in how many numbers of lanes. Now, it does pull in the volumes from the other pages, so you don't have to worry about that, or at least I found it to be true. And then you also have to code in, and so you have to give this a little bit of thought, is the conflicting vehicle type and vehicle movement. So the most severe vehicle movement to intersect the crossing. So if you're a pedestrian, what's that most severe conflict that you would have? And in the traffic signal, it's all stop controlled. So all of these would be stop controlled. And we're also going to say for the traffic signal that they will all be marked, that all the crossings are marked. So what we do need to do is go through here and code the number of lanes and make sure that they're correct. So again, going back, remember 1 and 5 are 3, 3 and 7 are 2 lanes. And then all the even numbers, the outbounds are just 1. So I'm going to go ahead and put those numbers in here. Crossing number 1, so there is 3. All the even numbers are 1. 3 is going to be 2, right? You also need to look and make sure, and usually it gets it right with the speed limits. So this is a minor approach, and it is 35 miles per hour. So that's correct. And then 4, you're crossing number 4 over here. Again, that's an even, and we'll go ahead and scoot that over there. That's an even, so that's outbound, so that's 1. That all stop controlled. Oh, one thing that I say they're all stop controlled, and that's not correct. So on the outbound ones, so these even ones, you do have permissive lefts, right? So we're going to do permissive left on those, and that's the most severe. So on all the even ones, we need to go through also and change those to permissive lefts. After you do all of this, you're going to come out with a score. It's a score from 0 to 6, with 6 being the most desirable. And then also, let's see, 5 has 3 lanes and 1. And then crossing 7 is that minor approach, so that's going to be 2 lanes. Everything else appears to be okay. So just keep in mind, the number of lanes you have to cross, and it does divide it up into the inbound and outbound of that intersection. So that's in case there is a multi-stage crossing. And then also what the most severe conflicting vehicle type would be. So if you were the conflict. right, so the two-way stop control, has a lot of the similar things, but if you look at the hover over on it, it doesn't divide out. I guess it anticipates that there's really not gonna be a multi-stage crossing on these. And so, it just has 1, 2, 3, and 4. So basically your 1 and your 3 are your major routes. So that's gonna be 4 lanes, and then 2 and 4 is your minor approach. So that's gonna be 3 lanes. So I don't know if you help, sometimes I forget, so I write it down or I keep that up or something. But if you go through, again, I got a little cheat sheet over here that I'm using, but the one, so that's 3 lanes. And then the 2 is I'm sorry, crossing 1 is actually not, it's 4 lanes, right? So this needs to change to 4. And then the crossing number 2 is the minor approach. So that's going to be 3 lanes. It is 35 miles per hour. Crossing number 3 is that's 4 lanes. And then the 4 is going to be 3 lanes because it's the minor approach. And then you look at the conflicting vehicle type here. And you're going to crossing number 1 is you're going across free flow traffic. And so, normally you don't mark those, I hope, or maybe, but we're going to say it's unmarked and it's free flowing because it is just a two-way stop control. So that's probably going to bring your head score down, just because it does take into account the fact that people might cross there anyway. And then your number 2, your most severe conflicting type is your permissive lefts. We'll say that it is marked, and then free flowing unmarked. And then the 4 is permissive left, I believe. Yes. All right, so now you're done. You have your scores for your pedestrians, for your traffic signal, and your two-way stop control. And that's a little more time intensive than the ones for the roundabout. So if you come down here to the roundabout, you can see, again, you have that pedestrian refuge there. And so you have the multi-stage crossing. And so all of your inbound or your yield control are your odds, and all your outbound and your free flowing movements then are your evens. And so same thing with your out of direction travel and your multi-stage crossing. In this case, again, there's that splitter island. This is a single lane roundabout, so that all of these should be, number of lanes should be 1 for the single lane. And then you just have to look and see, again, which ones are free flowing, which ones are yield controlled. And even though the yield control is, you have to go through the crossing to get to the actual yield sign, it's still considered yield control, I believe, on this CapEx. So you're still slowing down because you're going to have to yield. And so we're going to go ahead and mark all the odds as yield controlled and all the evens as free flowing. And then it picks up the volumes, the speeds. I think it picks up the speeds correctly. For the 1 lane, it should be 25 across the board, because that's what you want to try to get for your incoming speed in the roundabout. And then we're going to say that all the crossings that go through the splitter island, that they're all marked. And so again, yield controlled, free flowing, yield controlled for number 3, free flowing for number 4. And so, again, all odds should be yield controlled, all evens should be free flowing. They should all be marked, and they're all 1 lane. They're all 25 miles per hour. So it does pick up a lot of stuff from those inputs, but not everything. And then if you get to the 2x1, it's just a little bit more information, but basically in the directions where you have 2 lanes, now you're going to go 30 miles per hour because when you get a little wider, those speeds, those entry speeds for those roundabouts, they're a little bit higher. So if you look at it, all the 1, 2, 5, and 6, they're all single lane. And as far as we're modeling here, the 7, 8, 3, and 4, they're all 2 lanes. So And so as you're going through here, crossing one again was 1 and 2 were 1 lanes. 3 and 4 were 2 lanes, I think. Yeah. And one lane for 5 and 6. So should be 1 here. 7 and 8 were 7 and 8 were 1 lane. Is that right? Let me go back and look. That's why I forget, so I need to write it down. 7 and 8 are 2 lanes, and 5 and 6 are 1 lane. Yeah, okay. And so you want to make sure that the speeds correspond to whether it's a 1 lane or 2 lane, and in this case it does. You also want to make sure that you have your yield control and your free flowing correctly. So again, odds are yield control and evens are free flowing. So yield control. And so it looks like it picked those up that time. All right, so I think you're done with the roundabout. I did see a question in the chat. I am going to go ahead and answer that question. Is a multi-stage just if there's a pedestrian button in the middle? It doesn't specify whether it is or not. I would say if there's enough room for a pedestrian refuge, then it would be considered multi-stage. All right, so if there's actually a pedestrian refuge there. All right, so now we have all of the numbers for the pedestrian. So what you would do is you take this number again, it's a rating from 0 to 6, again with 6 being the highest. And you can see how they kind of, how they compare. Of course, your single lane roundabout is higher, and then you have all the way down here. This 2-way stop control probably just has a really low number because it has that free flow movement that the pedestrians would have to cross if they were going to cross there. And so you got to take that back and put it into your ICE form. I'll pop it back up here. And they go in the pedestrian accommodations right here. So you type those in. Okay, and then you would need to go and look at your bicycle accommodation score. Again, these, I mentioned before, but these tabs were added. It's something that Ohio DOT had as part of their process. And so they added in when they looked at these spreadsheets through that NCHRP process. And it looks very similar. The one thing I will say about bikes is instead of thinking about crossing now, you're thinking about the bikes going in the same direction as the motor vehicles. So it's a little bit different shift in thinking on how you're looking at this. You're not thinking about lanes you're crossing, you're thinking about lanes that you're next to. And it has the same inputs for speed up here. And the other thing it has is facility type. So in the purpose and needs for this project was the consideration of bicyclists and pedestrians. Right now, that doesn't have any sidewalks or shared use paths or bike lanes, and they're reconstructing the major roadway. So we're going to say that this major roadway has, we're going to construct an on-street lane, a bike lane. And then for the minor street facility, it doesn't have anything right now, and we're not reconstructing it. So we're just going to say it's the bikes are this lane is shared with vehicles. And so it has the same look to it, but again, you're not crossing, so you don't necessarily have to consider these. Instead of the crossings, it has northbound, southbound, eastbound, and westbound. So it's the direction in which the bicycle is traveling on the roadway. And the adjacent through lanes. So that's going to be 1 for all of them because we only have 1 lane going through in each direction. And so it's always going to be 1. It pulls the AET from the inputs that you provided. And then, of course, the conflicting control type. So the conflicting control type on this is the the dominant control type for the vehicle traffic moving perpendicular to the direction of the bicyclist. So if you're a northbound bicyclist, what's kind of control type do you have for the vehicles, the conflicting vehicles going in the perpendicular direction? And so since it's traffic signal, we're going to say each one of those is stop signal controlled. And then it asks some questions, and these are all going to be no, is if you have to go out of your direction of travel, are you riding between opposing directions? And the answer to that is no, and we don't have any ramps on our project, so the answer to that is no across the board. So you just need to make sure that you have one all the way through here, and we do. So all that should be good for our traffic signals. Then it gives you an intersection score that you would transfer to your sheet of 4.42. And then for the two-way stop control, then northbound, the perpendicular direction is going to be stop controlled, right? Because you have the minor two-way stop control. Everything else should be the same, but the same thing for the southbound. It's going to be stop controlled. When you get to eastbound, it's free flowing. That perpendicular direction is free flowing. So we'd want to hit free flowing and make sure all of these say no. So we don't have any ramps. So then you would have a score for your two-way stop control bike score here that you could transfer over to your ICE form. So just to take a little bit of time to talk about roundabouts and putting these values in is, so when you're taking a bike through a roundabout, in other countries, sometimes they do use bike lanes, and maybe some in the United States, but typically if you have a single lane roundabout, the speeds are pretty low. And so we generally design for the bike to kind of go around the roundabout like a vehicle. And so you wouldn't have necessarily bike lanes that go around that. So you could do one of two things. Well, in a single lane, you could design for them to go through it, or you could get a ramp, ramp them off, widen your sidewalk in that area another 5 feet, making a shared use path around. And that's usually what we recommend for the multi-lane. But for the single lane, we're going to say we're going to have them ride just within the roundabout. And so up here, you would need to change this to shared with vehicles all the way around. And then make sure that you have the one lane, and then the conflicting control type, it's all yield controlled. So that's really all you would need to do for that. I think everything else is good. No, yeah. So everything else is good on that single lane. We just had to make sure that when we looked at it, we knew that those bikes were kind of expected to go through the roundabout. If you add bike lanes to the roundabout, you'd have more conflict points, and there's a lot of design guidance for that, but we haven't, and I don't think we've done that in Kentucky yet. So there's also this, this 2x1 roundabout, and so you want to make sure that you have the right number. Your northbound and your southbound, they have the 2 lanes, and then the other should have 1 lane, which it does. It's all yield control. Again, if you want to look at it for the multi-lane, we encourage you to have the ramps off to the side and have the bike go around. So we're going to do a shared use path all the way around. And so the number that you would transfer over would be this 4.75. Okay, so now you have all the numbers you need from CapEx. Again, you would take them and you would put them on the ICE form. So that's where we transfer these over, right? And the next thing you want to look at, so you've done your capacity analysis, you know which ones you're going to move forward in your safety, high-level safety screening. And so we're going to use that SSI spreadsheet for that. And after that, we'll probably take a little bit of a break after we go through the spreadsheet. So this SSI score you can get from the SSI spreadsheet. We'll bring that up. All right. And you'll notice that, a lot of these, spreadsheets, they have the same look and feel. This is the NCHRP project that fed into the NCHRP 1087 as far as developing the tools for it or updating the tools. It has similar, statements of this is an as-is spreadsheet. And also, if you want more information, because there are a lot of formulas that go along with this particular methodology, there's a FHWA report called a SAFE system. I'll blow this up just a little bit. But it's a SAFE system-based framework and analytical methodology for addressing intersections. And there's a lot of details in there about how everything was developed. Great. It has, pretty minimal instructions. We'll get through this one pretty quick, so just hold on. And so the only required inputs for this SSI spreadsheet, because it's based on, conflict, we'll look at the tabs, but it's based on conflict points and likelihood and those types of things. So is how many lanes you have going through, we have 2 in each direction, and also the AET. So if you didn't have this other information, you could still use SSI. In our example, we do have the turning movement volumes. So if you have those, and also the speeds. So that's something that's really important too, is the posted speed limit. And so the volumes that you were given was the major roadway. And again, if you have projected volumes, I would use those. If you don't, you can use volumes that you have. Just make sure you know what those are on the form. And then 6,500 for the side minor approaches. Directional split, if you have that, you put that in. And then you would go through and you would put in your AM and your PM peaks for this. And so I've already put in the AM peaks because you watched me do that on the CapEx, and that may have been painful, but I'm going to go ahead and put into the PM peaks as well. And then the only other thing is it asks, what kind of signal phasing control, and it gives you choices in the pull down menu. In our case, I'm going to do protected, permitted over there to the right. So if you have your volumes, you can put these in as well. It gave you both the AM and PM peak in the example data. And then that you can change this too. It sets this up as the major movement, which is the northbound and southbound. You can change these. But they're set up well for our example. All right, so, and that's it. Once you put that in, that's really it. You don't even have to go through and toggle off intersections because it just automatically does all of them. But I do want to show you some of the stuff that's going on in the background. So if you pick these, again, there's a lot of formulas. You can learn more about it in that report, but it's based on exposure, severity, and conflicting traffic complexity. It has some coding for that, and it does that for each intersection type. So you can go through and see what those numbers are. But the numbers you need are on the results tab, and they're in this SSI score category. So it gives it a number. It scores a number from 0 to 100, with 100 being the most desirable for safety for that intersection. And so you can see the existing control type is this minor shock control, and it has a score of 61. We also looked at the traditional signal, and it had a score of 66, and then the 2 roundabout options are up here at the top. And so these are the scores that you would take and transfer over to your KYTC ICE form. And so, yeah. And so you would put those here. And then you've done, most of your analysis, but you still have these feasibility questions that you have to look at and answer. And so one is this practical to implement given the costs and the impacts and to either the right of way or environment. And so remember, you're very high level. So at this point, is this intersection practical? And you would answer that here, and so you could do yes, no, and maybe you just don't know at this point, but, you can answer that in this area. Does it meet the purpose and need? And so, yes, I did answer no on the two-way stop control because part of it was to provide, I think, better, improved mobility, and it doesn't really do that because the capacity, it significantly exceeds the capacity of a two-way stop control. So, and then does it address the key system performance criteria, looking at safety and capacity, also to, all users when you consider those. And I picked not sure for the roundabout one lane because again, we had that a little bit high B/C ratio in the future. So, but I wanted to go ahead and promote it on to stage 2. And then, just asks, is this alternative, are you gonna select it to advance to the next stage? And so there's also a place for justification over here. In addition to the form, you're going to want to attach your files that you use for CapEx and SSI, and you want to look at your 5 years of crash data as well. If you go to the top of the form, you'll see that you can submit this to your location engineer for the projects district. This is not an approval process; it's just a review. It goes into the projects file. If you have comments about, maybe you used a different method or approach or data, something like that, you can put that in the comments field here. All right, so is everybody still with me? Is everybody ready for a break? Are there any, let's see. Oh, there's only like a few questions. If we want to get the questions or go on to a break, let's go ahead and get the questions and then we'll go to a break. It looks like Amanda asked, what is the northbound 2 and the southbound 2? What type of intersection would that apply to? I think when you asked that question, that was the roundabout, the hybrid, where we had 2 lanes going. Let's see. Let me bring up the CapEx. Okay, so the northbound and southbound 2, I think this is what you were referring to. So it would be if we had to expand out for the hybrid 2-lane roundabout in the north-south direction. So 7, 8, 3, and 4 would be 2 lanes, and then the minor approaches would be 1 lane. And then on the SSI sheet, roadway geometry section, is that per direction? Let me bring up the SSI. Oops, didn't work. So it's written, I struggled with this too because it says in 1 direction, but I think it really means 1 leg. So it's basically how many through lanes are there for both the major and the minor. And so for our example, it's going to be 2 through lanes. Or 1, I'm sorry, well, how many through lanes in each, not in each direction, but total lanes. And so it's written poorly here. I struggled with that too, but I went back to how they developed this, and I'm pretty sure since if it's a 2-lane road, then this is 2. If it's a 4-lane road, it would be 4. And I think that's all the questions that I see in the chat, unless Jeff, are there any other questions? I don't see them.
I didn't see any, Jill. Thank
Okay.
you.
All right. So we're going to take a break. It is 10:36. Let's try to come back at maybe 10. Let's take go to 10:55. So I'll put that in the chat. Okay, well, that was a well-deserved break. We went through our first part of fun with spreadsheets, so we'll do the second part here in a little bit. So, whoops.
Jill, you do have a question that came in over break. If you want to take it, it deals with some of the material you've already covered here.
Okay, so, the CapEx. Yes, so Jeff, if you wouldn't mind putting the NAS download link in there. The CapEx spreadsheet that the original one, I guess, was developed around 2018 or so, and it's on FHWA's website, and but it's been updated as part of that NCHRP process. And it has, again, the biggest updates are those two, the multimodal tabs. So it is available through that NCHRP download if you go underneath resources. I think that's all the questions. So, oh, let's see. Yeah, there it is. Jeff put it in. All right, so before we get started with a few more spreadsheets, we're going to do a little bit of interaction just to get going again. And this question isn't meant to be hard, but intersection is what type of intersection design with one main intersection and two secondary intersections that are linked by connector road in any quadrant of the intersection. What type of intersection is that called? Just you can guess it in your head. This isn't hard, by the way. Just trying to get some interaction. We already talked about it a little bit earlier today. Yeah, that's right. It's not meant to be hard. It's just it's the quadrant roadway. So again, it takes some of those turning movements off the main line, the main intersection, and puts them onto these two nodes on the quadrant. Well, I think we have a few of those in Kentucky. I know there's one in northern Kentucky, at least, and a few here and there. All right, so we're going to get into the stage 2. So this is more like when you're doing in preliminary line and grade, when you're doing your alternative alignment selections and you're looking at, maybe different alternates, right, left, down the middle, or maybe different cross sections. That's kind of what we're looking at here, and just trying to compare all the different alternates in more detail than we did in the screening process. So we're going to take those alternates that we screened through in stage 1 and look at those in more detail. And so you're going to look at, again, the cost, the safety, operations. By this time, you probably had your public involvement. You maybe had a public meeting, or you met with an official or stakeholders. You have a better idea of what your right-of-way and utility impacts are, and your environmental impacts, and then also how your users, how you're going to accommodate those. So the first thing that you want to look at again is that operational analysis. And this is the point where the process should be similar to what we've done in the past, and looking at the operations of intersections. And you want to use some sort of high capacity manual based traffic analysis, like maybe HCS or something like that, to look at your intersections. If you can also, for intersections that aren't very complex, or you could use this planning and preliminary engineering applications tool. It's HCM based. It requires a little bit more data than that CDAT does, but not a whole lot. And so we will take a look at that. Again, that's just one of the software that's available. If you're going to use HCS or whatever you're more comfortable with to look at the intersections, then use that software. The performance measures you want to come out with are your control delay, your volume to capacity ratio, and your intersection LOS. And so there are some cases where you have really complex intersections, or you have intersections that are closely spaced, so they might impact each other, the traffic and the movements from those. In those cases, you might want to consider doing a micro simulation. KYTC has some micro simulation guidance on the Division of Planning website if you want to go look at that. But again, this operational analysis should be similar to what you would do in your regular process when you're looking at intersections. And then you also want to do like a more detailed safety analysis. And so SPICE process recommends using SPICE. And its performance measures or crash predictions based off SPS and CMAPs. And we'll take a look at that in greater detail here in a minute. But there's also you want to look at the safety for your bikes and peds. We've already done that with that CAPEX tool. It gives that 0 to 6 rating. So there's those CAPEX multimodal tools, and you get an intersection score. that you can report back. But also, if you have a lot of bikes and peds, there's this thing called the design flags tool, but it's optional. And your performance measure are those yellow and red flags or a no flag. And so I do want to mention that there are some alternative intersections like that Spice, it doesn't address. And so for those, you might want to just look at other tools like SSI or number of conflict points. Again, we need to keep it flexible enough, but also look at the different safety of the different intersections in some way. So at this point too, you're going through, you're close to the end of your preliminary engineering process. And so you have a better idea of your cost estimates. And these cost estimates that we're looking at for ICE are just for the intersection. You may have a really long corridor, but you're looking at that particular intersection and the comparison of costs of one intersection type to another. So you want not only the cost to build, so what's your right-of-way cost, what's your cost to construct, but you also want to consider these life cycle costs. And so for less complex intersections, that may just be a discussion of, hey, what are some of the costs we're going to have to account for, the maintenance and the operation, and also, the crash costs. If you Spice, you come out with predicted crashes, so you can equate that to, some crash costs and cost of delay from your capacity software. So all those things need to be considered. To what level it's discussed or included or calculated, it really kind of depends on the complexity of your intersection. And so there's also something called the life cycle cost estimation tool. And it was developed specifically, it's optional, it's an optional tool, but it was developed specifically for alternative intersections. So it has all these intersections in it, and we'll take a quick look at that tool as well. See. Okay, before we go to the next slide, we're going to go ahead and demo. So what I want to look at is that PPEAG tool. Is that planning level, I guess for capacity analysis for stage 2, if you choose to use it. Again, there's highway capacity software out there, whatever you would normally use for your intersections. But I'm going to go ahead and bring up the PPEAG. Oops. Well, before we do that, it might be a good idea to look at the form, because it does have some information on it about stage 2. So your stage 2 form, it has regular information that we talk about, the operational analysis, the safety performance of the motor vehicles, context and equity, your pedestrian and bicycle safety, as well as the ratings, and then some information on impacts, public input, and costs. And again, it has those information on how to fill that out. So if you go to your PPEAG tool, and you may have used this before. Yeah, it has a similar look and feel as all of the other spreadsheets that were updated or developed as part of this project. It originated from the NCHRP report 825, Planning and Preliminary Engineering Application Guide to Highway Capacity Manual. And so if you go to the README, it has some basic instructions. Really, the biggest thing to note is your major roadway is these nodes from 2 to 6, and your minor is 4 to 8. And that has some other instructions as well. And then it has global inputs. So the things that are in yellow are with red text, you have to input information to those. I've already done that, so I'm not going to go through the painful process of entering in the information into the spreadsheet again. But here's kind of the name of it. You do have to pick your major roadway. So for our AM peak, that major roadway was that northbound. You want to do your speed limit. So it was 45 miles per hour. A peak hour factor is usually between 0.9 and 1. We're going to use 0.95%. Heavy vehicles, we said, was 5%. And then the distance between intersections. And so that wasn't in the information I gave you, but we're going to say that it's about 1,200 feet to the next intersection. And then the length of the left turn lane, we're gonna say, and of course you can change this for different scenarios, but we're gonna say it's 200 feet. We don't have a median, so we didn't put any width in for the median between the directions of travel. And then it doesn't ask you for signal timings, but it does have some information, requests some practical cycle lengths, both minimum and maximum. And so, for this example, I put 40 as the minimum and 120 is the maximum. And a base saturation flow rate per lane. And so I put in 1900. That was the, I guess the default that was on the CDAT program for urban areas was the 1900. So I put that in there as well. Again, if you have more information on your project, you know, and the project development team agrees, you can change these to whatever the information you have for your project. I'm going to say that we didn't have effective greens. These are kind of defaults here. And then I use the default for the arrival pattern. And then the volume growth right here. So I use all of these defaults. This is where you put in your turning movement counts for your peak hour. So I've already done that from the AM peak. You have to be careful because I think it's in a different order than some of the other forms that we've been using, but they're left through right here. Okay, once you do that, you'll need to go to each individual tab and see if there's anything else that you need to put in. And so if you skip over the summary output, you can go to the signal tab. And the first thing it asks for is your pedestrian level. And it has none, low, medium, high, and very high. And so my first question would be, well, I don't know. I don't know what my pedestrian level is going to be in 40 years, but also, what does that mean? How many does that need to be? And so our recommendation was that the only place I've seen that number in this process is in SPICE. I'm going to bring up SPICE for just a second because we're going to talk about it later. So if you go down to the inputs in SPICE, it does provide like numbers. They're daily numbers. They're not hourly. So for low, medium, and high rates of pedestrians. And so I would just keep everything the same. I would use these numbers for low, medium, and high. And then again, those are daily numbers. And again, you don't know for sure. You probably don't have head counts. I don't know how you forecast head counts, but you would need to use your best engineering judgment, make sure your project team's in agreement. So we're going to say that's going to be low. You could put medium, high, whatever the case is for your intersection. And then it has the number of lanes in the lane group. So again, the eastbound and westbound have that through and right combined. And then the northbound and the southbound have rights through and lefts. There's no parking on any of our roadways. So we just put no across the board. And then left turn phasing, is it protected or permitted? And those are really the only options. So I have permitted right here because it's a protected permitted phase. Right turns are permitted on red, so I left that. And we really don't have any other, I don't have any other adjustment factors. All right, so, and there's some other information over here to the right, kind of, if you need to look at it, about how these numbers, they come up with the numbers. Oops, there you go. All right, so for the cycle, we don't know what the cycle length is. If you read this green box here, it says you can enter in a cycle length, a suggested cycle length, or a default cycle length in this D46, which I entered in 60. And then you can go to the data menu bar, and there's an application called Solver. Well, that wasn't the case on mine. I actually had to add in an application for the solver. And so I don't know if you can see that, but there's a solver app, and you add it in. And it says to use the evolutionary method. So when I click on solver, if you haven't added in, again, it's an add-in. It might be on your data tab, I don't know, but mine came up on my main menu. I'm sure there's a way to change that. And to use the evolutionary method, oops, it's this model type. Let's see. One of these engines, you pick on engines and it has different ones and they're standard evolutionary. And once you pick standard evolutionary, after you put your number in, D46 for just a number to start with, and it'll start doing iterations for that. Then let me go back over here. Whoops, that thing is touchy. Let me bring it back over. Okay, for your cycle length, then make sure that's highlighted and you press this play button basically, and it will go through and it will finally come up with the what they decide is an optimum cycle length in this program. And so in this case, it came up to be about 75 seconds. It has some, I just use the defaults, but it has some lost time per phase and then saturation. And I think that's all the inputs for the signal. And this is still in here, but we didn't carry that forward as an option. But this is what the two-way stop control looks like for the PPAG. And then the single lane roundabout. So there's no inputs for the single lane roundabout. You'll notice that it does come up with that volume capacity ratio that's pretty much the same as what the CDAT did. So it's 1.14. And then all the other ones are under 1. But it has an overall LOS of F there for the future year. Again, I would probably put it in a different type of software, or the one thing that I did is I ran it with current numbers, like the traffic numbers for 2024. And when I did that, just to see what it would do, see how it functioned. So let me find that. With those numbers, the roundabout, you know, it's at a LSB with the numbers from 2024. So it could function at LSB for a really long time. Probably you could do a little bit of sensitivity analysis to see when it breaks, but I would say don't necessarily dismiss this as an alternate. Certainly there's ways you can improve the function of the roundabout, that kind of thing. All right, so if we go back to the forecasted numbers, if you look at the multi-lane roundabout, where you have 2 going in the north. Actually, I just left it 2 in the north since this is based off of AM peak values, volumes, and left it 1 in the southbound, and then you have 2 opposing lanes for that westbound. And it functions very well in future year. And I think it does, like lots of other types, but those are the only ones that we've moved forward in the screening process. And it has a summary of outputs. And so you can pick which ones we're going to look at here. So I guess we didn't look at these. These are what we looked at. And we have a couple of them. It's that two-way stop control, again, is just that existing condition we knew it wouldn't work. The one that has at least one leg that's over a VDC of 1. All right, so that's what these numbers are what you would put into your form. So you would bring it back into your ICE form here, stage 2. So in addition to some just regular information, what your design vehicle might be. So as you move forward with your design, you'll have some idea of some of the details for your design. And then also, what traffic software did you use? And in our example, we're going to say we use PPAG and SPICE for both the capacity and the safety analysis. And so you would take those numbers and you would put them in here, LOS. And so I did both opening year and design year, so I could see the comparison. And this is kind of what I got. Okay, so now we're gonna go to the motor vehicle safety performance. We're gonna look at SPICE. And again, same kind of look and feel. It's an as is. They didn't change this much, by the way. So the previous version of SPICE that's out there is very much like this. Really, the only change, and if you go through the instructions, there's some instructions here, but really the only change was pretty minor. I don't know that it impacts what we're doing here today. But the FHWA website also has some user manuals for both SPICE and CAPEX, and so that one is still very applicable to this this program. If you want to look at it, it has a lot of detail in it. It gives you a kind of a key of what's required data, what's optional, and what's plating level defaults. Where's the, here we go. No, change log. There's a tab I'm trying to find. Okay, so here's the project information. If you have a CAPEX file, you can load your CAPEX file into this, and these fields will populate with whatever you put in CAPEX. I will say though that these are the only fields that populate if you load into CAPEX. It would be nice if all these spreadsheets talk to each other. I think they've mentioned that and as part of the resource search, but they don't really. But this information does fill in if you load your CAPEX form. Again, it might be easier just to type it in rather than try to figure out where your CAPEX form is, but it is here. And this is the tab I was looking for. So on the definitions tab, there's this SPICE is based on SPF's safety performance functions from the Highway Safety Manual and CMS. And so these SPFs are based off of, case studies and things that they've looked at. And they have applicable ranges of ADT and that kind of thing. So if you have an example that's outside of that range, it's going to let you know. It kind of tells you what these are here. And it's also kind of neat in that it has these, hover over things that gives you some definitions of what some of these things are. So. And so SPICE, it's kind of minimal inputs again, but you do have to say whether it's an at-grade intersection or ramp terminals. So it does have different calculations for those. And then your analysis year, you either have to have opening year only or an opening and design year. And really, if you can do that opening and design year, that way you can get crashes over the lifetime of your design, and that way you can use it for a cost benefit analysis. But if you don't, you can just put in the opening year. So in our example, we're going to say the opening year is 2024, the design year is 2044. They ask for the facility types, and then the number of legs. And then you put in your opening year in your design year, major and minor road ADTs. So I've done that already from the information we were given. And then down here, it's going to give you options of what you want to look at in SPICE. So these are the intersection control options that are in SPICE. It covers all the ones that we're looking at today. So it has the traffic signal. If you have a different configuration of a traffic signal, you can look at that as well. The minor road stop, we'll keep it in there just to look at it. 1-lane roundabout, and then the 2-lane roundabout. It doesn't specifically cover a hybrid, but we have the two lane and 1-lane in there. And let's see. So we picked all the ones that we moved forward with. And so your inputs, again, they're kind of minimal. If you have a traffic signal, it's asked for the number of approaches with left turn lanes. And so all the approaches have left turn lanes at that traffic signal. And then the number of approaches with right turn lanes, and that's just the major roadways. On the minor road stop, it asks for the number of uncontrolled approaches with left turn lanes. Well, the uncontrolled is just that north-south movement. So that's 2. And then the uncontrolled approaches for the right turn lanes, that's 2 as well. And that's all that's required, but if you have the information that's down here, it would help as well for, I guess, the use of the CMF. And so it asks if lighting is present. And then in our example, we're just gonna say yes, it has yes or no. Number of approaches that have either permissive protected or protected left turn phase, and we're just gonna say that they all have the permissive protected. And then let's see, number of approaches with right turn on red prohibited, they can all turn right on red. We don't have any red light cameras in Kentucky, so that's no. Pedestrian volume by activity level, and so that's where it gives those numbers. And so we're just gonna put low there. And for our example, I think it automatically populates this from if you pick that. If you don't have a specific number, but if you do, you can type that in. And then the maximum number of lanes crossed by a pedestrian. And so that would be 4 lanes because it would be the north-south movement. There are no bus stops, schools, or liquor stores near our intersection, so we place that in there as well. And so that's really all that you need for that SSI. And you can go, there's another tab if you have ramp terminal inputs. So there's this other tab. But you can go to the results, and what it's going to give you is you hit compute, which I've already done, the computer update results. And then it'll give you the predicted crashes, both your total crashes and your fatal injury crashes for the 1-lane roundabout, 2-lane roundabout, your minor stop, and your traffic signal are the ones we picked. So it'll do that for both the opening year. It will do it for the design year, and then it's gonna do a total life cycle of your project. And these are the numbers if you have them. If you're done an opening year and a design year, these are the numbers that you report on your form, KYTC ICE form. If you don't, you could report what you have and then make sure you know what they are. I mentioned that if you have an alternative intersection control strategy that's outside the AETs that were used to formulate the SPF, then it's gonna say no here. And in this case, that's that minor road stop, which really, again, we're using just as a comparison for existing situations. So the 1-lane roundabout, you can see the total and the fatal injuries are, again, significantly lower than, say, the traffic signal. And then the 2-lane roundabout, one thing about 2-lane roundabouts is they're still very good at, have very good performance as far as reducing fatal and serious injury collisions, but you're still seeing a lot of those, maybe total collisions like property damage only with side swipes and that type of thing. So if you open one up and, the single lanes perform, you don't have the side swipes because generally, you might have people going in, maybe they don't understand the yield control, but you'll generally see that they have better safety ratings overall, but that both of the roundabouts have pretty good safety ratings as far as fatalities and injuries. And so again, you take these numbers and you place them in the form here. Let's see. So many spreadsheets. Okay. So you place them in here. So we did the capacity, and here's the SPICE. So for motor vehicles. And we placed all that in there for consideration when you're selecting your intersection type. Okay, so the next thing that you want to look at is your context and equity. And so that's part of this ICE process. One thing I would say, if you go back to the instructions, there's like, well, what are we supposed to talk about here? Well, if you've done an environmental justice study, and it was completed for this project, and you have findings, really the populations you want to look at are those with disabilities, those living in poverty, populations under 10 or over 74, those that can't drive, 0-car households, those types of things. And so you want to summarize that on that form so that we know that there's notable populations of those types of people that might need to use alternate methods of mobility than a car. So that, along with the context of the area, is what you would summarize here. And then the second tab, we're going to look at the pedestrian activity levels. So these match the spice levels here in the pull down. And also the bike activity level. Again, may not have those, but you have some idea of what the land use might be in the future and what you might see as far as pedestrians and bicycles. And then, of course, this is still the same pull down, same intersections we've looked at. And all we did here is we transferred over the bike and ped accommodation ratings from CapEx from that stage 1. Now, alternatively, there's another spreadsheet that we'll take a look at. Probably could go ahead and do that now. That design flags calculator. Again, it's optional. So, but I do want you to know that it's there if you want to use it. And so, it was developed as part of an NCHRP report guide for pedestrian and bicycle safety at alternative and other intersections and interchanges. So it's specifically, for alternative intersections and interchanges. And it provides some brief instructions. And so basically you're gonna tell whether each flag is a yellow flag, if it meets the yellow flag criteria, a red flag, or no flag, or if it's not applicable. And each scenario in the tab here is an intersection control type. And so, one might be a signal, one might be a roundabout, one might be stop control, that kind of thing. And basically you have to go to that report though to figure out the parameters of whether or not it's in the report, whether or not your flag is yellow, red, or no flag. And so you would come here, you can see some of the flags are specifically for pedestrians. Some of the flags are just for bicycles, and then some of the flags in the middle are for both. And again, you can pull down and you have that choice, but you have to go to that report to figure out whether or not the parameter is red, yellow. And in the results, it's pretty simple. It just adds up and tells you what percentage, and then it shows it graphically. So if you wanted to use that, if you had in an area where you had a lot of pedestrians or a lot of bicycles, or you're expecting a lot, then you can use that tool in place of the ratings from CapEx. And instead of putting a number, you could put how many red flags, how many yellow flags, that type of thing. And so the next thing you would think about is your environmental and your utility and right-of-way impacts. And again, these should be specific to the intersection. So if they're all pretty much the same for every intersection, then you really don't have to get a lot of detail, but it's basically a comparison. So maybe you have X number of parcels for this one and X plus 2 parcels for this one, or something like that. So again, or environmental impacts, you're hitting in some sort of resource here, but not with this one. So this is where you would note those types of things. And then this is where you would say how much the public really loved your alternative intersection control type, or not, I guess. But this is where you would summarize your public input that you received if you went to the public. And we'll spend a little bit of time talking about this intersection costs. Again, you're at the end of preliminary line grade, so you do have a better idea of the costs. So there's the cost to build the intersection, but there's also, again, those other costs that you need to consider. But when you put in here the cost to build, you need to also include what does that estimate include? And so if you're doing a signalized intersection, you may just be hanging a signal, or you may be constructing turn lanes as well. You may need some crosswalk equipment, that type of thing. One thing I wanted to mention about the 2-lane roundabout is if you have 2 lanes going into a roundabout, or if you have a pedestrian crossing more than 1 lane at a roundabout, PROAG requires either a raised crossing or some sort of head signal now. So you would have to include those in your costs as well, not just to initial cost, but the cost to maintain those signals too. So roundabout, 1-lane roundabout does not require that. But it does require, all the roundabouts require lighting. So that's something to consider as well. But as far as the life cycle costs, you can actually put a cost there, and we'll go through the tool, the life cycle cost estimation tool, in a minute. But you could also do like a discussion of the life cycle costs if it's a simple, like if it's a simple intersection and you don't want to spend a lot of detail on trying to calculate these costs out. Then you can talk about, well, you know, we calculated that once one intersection has 4 to 5 times more crashes, so the predicted crashes according to SPICE. So maybe that cost of collision is predicted is going to be 4 to 5 times greater. So you can use some ratios for the simple intersections. But this needs to come into play though. You need to think about, okay, we have the cost to build, but we also have the cost to maintain and the cost to operate, and maybe the cost of delay or the cost of the collisions that are going to occur each predicted to occur at each intersection. And then there's let's go ahead and get to the last. This is the last spreadsheet, you all, except for the form here. But this is the last spreadsheet. Thanks so much for hanging on with me here. All right. So this life cycle cost estimating tool, again, it was developed as part of, I think, another research project, but it was updated as part of this project. And it's specific to the alternative intersection types. And it's not terribly hard to use. It is an extra step. It requires some organizational information to be put in, and also what type of intersection type you have. And it does require some volumes. So you're operating, it requires open year and design year. When it was taken, their AM and PM peaks, and then if you have peak hour volumes, it tells you how to get a AM peak hour volume, I guess, over here, vehicles per hour total. So you just add them all up, basically, and put them there. And so that's for the AM opening and design and the PM opening and design. And you can select whatever alternatives, intersections you want to look at here. I haven't played with this a lot, and I don't have all the information in. I just wanted you to know that it's out there if you want to use it, and sort of how the information needed to put into it, and how it calculates it. So it does look at delay information. So if you get that from your analysis, your AM peak, your PM peak, optionally it has weekends for each of the intersection types, and then has the cost parameters. And so it has the value of time, which I think they use the TTI. KYTC may have other values that they use for the value of time as far as delay. And it has the value of the crashes. So I know that KYTC on their GDSA website, they have their comprehensive crash costs by all the different severity levels and some combinations of the severity levels. And so you could get those costs and put those in here instead of the defaults. And then it does have like the total design and construction costs and the total right-of-way costs here for each of the intersections. And then it has some default costs for these. And I would really suggest that if KYTC, or if they start using these a lot, that probably we need to come up with some Kentucky values rather than the default values. But it considers for different intersection types, you may have lighting, you may have signal retiming or cost of power, the landscape costs here. Down here is your safety information. So this is your total crashes and your fatal injury that you would pull off of SPICE. And then it has outputs like this, and it'll give you, what the total net present value of the cost of the intersection is, given the safety, the delay, the opening costs, and then just the cost to build. And so that tool is out there. You could use that. And plug those costs in here. At the end, when you're done with everything, other considerations, so on the form, other considerations, maybe the resiliency of the intersection, or anything else that you want to consider or discuss, want to bring up in your decision-making process when you choose that intersection alternative. And so in our example, though, the project development team decided to go with the 1-lane roundabout. It had the best safety rating, and they looked at it and it did accommodate traffic volumes for the near term. They're gonna suggest that they design it to more easily accommodate a 2+1 in the future, but for now, they're gonna use it as a 1-lane roundabout. So I think let me go back to my PowerPoint. We're just about done here. Okay. So stage 2, you go through that process. You do want to make sure that you consider all users as you move forward through your more detailed design process of your intersection. So just use the notes that you have from your ICE, and your contexts are going to be completely different. On the top of the screen, you have an urban core context. You're going to have wide sidewalks, or you're going to have either bike lanes or sharrows, or any place where you're expecting to have a whole lot of users. You want to consider that in your design. But in rural areas, you may never see a pedestrian. You may have shoulders. If they do want to use it, you may not need crosswalks. You have shoulders for bike lanes. So that context is just really important. But the other thing is say in the bottom, yeah, there's nothing out there right now, but if that's a bypass, there's probably going to be a Walmart pop up on that corner, and then there's going to be some other development. So you want to consider the future of your intersection as well. So when you get to the end of stage 2, you evaluated your screened alternatives in more detail. This is really not different than what we've done sometimes on intersections as part of the PLNG process before. You're going to compare that performance and those qualitative factors and that little level of effort that you're using for these intersections, since we're doing more of them and maybe some of them are really simple. You want to make sure that it's commensurate with the complexity of that intersection. And so you're going to have that ICE form. You're going to attach it along with the spreadsheets that you used for the numbers to the DES. And when the DES is signed with that selected alternative for your intersection, then it's approved. And we went over the stage 2 form already. So with that, I think that's about it. We can open it up to questions. You can either type them in the chat, or if you let Jeff know, I think he can unmute you. I don't see any questions. But if you have any, that's my email there. I will say I'm less than 48 hours away from the beach. I'm on vacation next week. So if I don't respond immediately, if you have questions for me, I'll respond when I get back. So, but yeah, go ahead and send those in if you have any questions. All right. Well, if there's no other questions or comments, I really appreciate you all attending. It's a really long webinar. There's a lot of spreadsheets. Wow, lots of spreadsheets. So if you have any questions, just let me know. Wendy too, she's on the line. She'd be happy to answer. So y'all have a great day, great afternoon, and I'll see you later.
Great job, Jill.
Thanks.